In this session, let us continue to discuss Fourier series expansion. So, in the last 5 sessions, we had seen introduction Fourier series expansion in the interval minus L to L, minus pi to pi, 0 to 2 pi, and 0 to 2L. So, let us continue to discuss another topic which is called as a half range Fourier series. So, what is half range Fourier series? So, half range Fourier expansions of a function f of x we are going to discuss. So why we need this? What is this exactly? In some application of the Fourier series, it becomes necessary to expand f of x over half the interval, which contains only cosine and sine terms. Either cosine terms will be there or only the sine terms will be there. And also, one more thing which we want to tell about the half range expansion is the series which contains only cosine terms over the half interval 0 to L, that L can take any value, are called as half range Fourier cosine series. And if the series contains only the sine terms, then it becomes half range Fourier sine series. So what is half range Fourier cosine series is? The half range. So as the name itself indicates, in the range taken, only the half will be considered. For example, if you take 0 to 2 pi, the half of which is 0 to pi, only that will be considered. So what is it? Is nothing but only the cosine terms are segregated as well as sine terms are segregated. Separately you will be getting it. So half range cosine series for f of x over the interval 0 to L that we are discussing here. So half range cosine series in the interval 0 to L is given by f of x is equal to a naught by 2 plus summation n varies from 1 to infinity a n cos n pi x by L, where a naught has the same formula as 2 by L integral 0 to L f of x dx and a n is 2 by L integral 0 to L f of x cos n pi x dx. You need to remember the formulas exactly how they are. So here we doesn't even know it like f of x is even or odd, but still the formula is 2 by L, whereas in the previous cases and all, only when it is even we had taken 2 times of integral. So you need to have a difference between these and that. So in particular, if L becomes pi, then we will be having half range Fourier cosine and sine series in the interval 0 to pi. So if L takes the value, so this is the formula. F of x is a naught by 2 plus summation n varies from 1 to infinity a n cos nx, and a naught is 2 by pi integral 0 to pi f of x dx and a n is 2 by pi integral 0 to pi f of x cos nx dx. So and that is about a half range Fourier cosine series. So here half range Fourier sine series. Let us see in the interval 0 to L. So in the interval 0 to L, only Bn term was there. So Bn, because in the main Fourier series expansion, f of x is equal to a naught by 2 plus an and Bn. So sine terms only which is having only in the term Bn. So this alone will be there in half range sine series. What is Bn? Bn is 2 by L integral 0 to L f of x sine n pi x by L into dx. So in particular, if I take L is equal to pi, we get half range sine series for f of x over the interval 0 to pi, and it has been given by this formula, and Bn is evaluated by using this formula. Let us see an example. Find the half range sine series for the function f of x is equal to this in the interval 0 to L. So 0 to L itself is the half range. So since it is sine series, only this is a Fourier series expansion that we have. It means that we need to evaluate only Bn. So the formula for Bn in the interval 0 to L is 2 by L integral 0 to L f of x sine n pi x by L into dx. Substitute for f of x and then multiply this x inside the bracket so that you will have only two functions, and you can apply Bernoulli's rule to integrate and get the solution. So when we integrate it, 2 by L outside, just keep it as it is. First function, integral of the second, and differentiation of this and integration of this. Again, differentiation of this is minus 2 and integration of this is cos n pi x by L divided by n pi L the whole cube between the limits 0 and L. So let us simplify further. When we do simplification with the substitution of limit, we get this as 2 by L minus 2 L cube by n cube by cube cos n pi minus cos 0. So cos n pi is minus 1 to the power of n and cos 0 is 1. So this is what the answer we get for Bn. So substitute the value of Bn in the Fourier series expansion, half range Fourier sine series. So this is what is the expansion that we get. So if it is the answer that we have completed, so we can go further ahead. Like when we substitute for bn, we had got this, and we can further simplify. 4l square by pi cube is the constant because under the summation only n takes the values. So keep only the n terms inside the summation. So now this term, especially 1 minus of minus 1 to the power of n, takes the value 0 when n is even. You can observe when n is even is nothing but 2, 4, 6 and so on. When n is even, this minus 1 to the power of even power becomes plus 1. Plus 1 minus 1 will be 0. So that is the reason when n is even, the entire term, this entire term becomes 0. When n is odd, we get the 2. When n is odd, we get the value as 2. So therefore, summation n is equal to 1 to infinity can be written as summation n is equal to 135, because summation exists only for these values. And this term gives us 2. So 2 has been entered here. And divide by n cube sine n pi x by l. So take out this 2 by n cube outside the summation. So it is 2 alone can be taken outside. So it is 8l square by pi cube summation, and the n terms are there under the summation. So now further simplifying, since n is taking only the odd value, the nth number of an odd 1, 3, 5, 7 and so on can be written as 2n plus 1 whole cube. Sine of n is again taking only the odd values, so we can write it as 2n plus 1 into pi x by l. So this is a Fourier series expansion of half-range sine series. Let us see another example. Find the half-range Fourier cosine series of the function. This here f of x is taking two values, kx and k into l minus x in the interval 0 to l. The interval 0 to l has been split up into two parts. One is 0 to l by 2 and the other one is l by 2 to l. So since it is a Fourier cosine expansion, half range, so it is a0 and an terms will be there in the series. So it means that we have to evaluate a0 as well as an. The a0 formula is this and an formula is this. So let us do evaluation of a0 first. 2 by l integral 0 to l f of x dx, 2 by l, and substitute for integral 0 to l as two parts, 0 to l by 2 and l by 2 to l. And when the limits are 0 to l by 2, f of x is kx. And when the limits are l by 2 to l, f of x is k into l minus x. So do the integration and then substitute the limits. We get this answer as kl by 2. Then an is, this is a formula that we have. And again splitting of the integral need to be done, and integration by parts or apply the Bernoulli's rule need to be done. And on integration, so do the integration carefully. So this is what we do, we get the integration applying the Bernoulli's rule between the limit 0 and l by 2, l by 2 to l. When we substitute the limit, we get this expansions, and on simplifying we get this answer for an. So for going further, so when we simplify further, we get the expansion as this, and half-range cosine series of f of x over the interval 0 to l is this. Substitute for a0 and substitute for an. So when we simplify further, kl by 4, 2k l by pi square into 1 by n square, 2 cos n pi by 2, and this is the term we have written as it is. So this is about the half-range Fourier sine and cosine series. So thank you. If there is any doubts or any clarifications, get back to us, and you can also refer the notes which has been uploaded in the Google class. Thank you all.